Look up at the night sky. Every star you see is a sun, a blazing ball of fire like our own. Many of these stars have planets orbiting them, worlds unseen but perhaps teeming with life. Our sun is just one of billions in the Milky Way galaxy, a vast spiral of stars, gas, and dust. And the Milky Way itself is just one of billions upon billions of galaxies scattered throughout the universe. The universe is vast, a concept almost impossible for our human minds to grasp. It's a realm of unimaginable distances, mind-boggling scales, and breathtaking beauty. Our planet, our solar system, even our galaxy, shrinks to insignificance when compared to the sheer scale of the cosmos. Yet, this vast universe is our home, the grand stage upon which the drama of life, and indeed the universe itself, unfolds. The universe is not a static, unchanging place. Stars are born in fiery explosions, live out their lives, and eventually die, sometimes in spectacular supernovae that briefly outshine entire galaxies. Black holes, objects of immense density and gravity, lurk in the hearts of galaxies, warping space and time. And the universe itself is expanding, carrying galaxies away from each other like cosmic raisins in a rising loaf of bread. We are fortunate to live in a time when we are beginning to understand the universe around us. Powerful telescopes allow us to peer deep into space, observing galaxies billions of light years away. Sophisticated spacecraft have visited most of the planets in our solar system, beaming back stunning images and valuable data. And theoretical physicists are developing mind-bending models that attempt to explain the origin, evolution, and ultimate fate of the universe. To explore the vastness of the universe, we need a measuring stick that can stretch across the cosmos. The distances are so vast that using familiar units like miles or kilometers becomes impractical. Instead, astronomers use the light year, the distance light travels in 1 year. Light, the fastest thing in the universe, zips along at approximately 186,000 miles per second. In 1 year, it covers a staggering 5.88 trillion miles, a distance we call a light year. To put this in perspective, the nearest star to our sun, Proxima Centauri, is a little over 4 light years away. This means the light we see from Proxima Centauri tonight left the star over 4 years ago. We are looking back in time when we observe distant objects in the universe. The more distant an object, the farther back in time we are seeing. Our galaxy, the Milky Way, is about 100,000 light years across. That means it takes light, traveling at the mind-boggling speed of 186,000 miles per second, 100,000 years to cross from one side of our galaxy to the other. Yet, as vast as our galaxy is, it's just a tiny speck in the observable universe, the portion of the universe we can see from Earth. The observable universe is estimated to be about 93 billion light-years in diameter. This means that light from the most distant objects we can see has been traveling towards us for almost the entire history of the universe. And remember, the universe is still expanding, so the actual size of the universe is likely much larger than what we can observe. When we observe distant objects in the universe, we are actually looking back in time. The more distant an object, the farther back in time we are seeing. Our galaxy, the Milky Way, is about 100,000 light-years across. That means it takes light, traveling at the mind-boggling speed of 186,000 miles per second, 100,000 years to cross from one side of our galaxy to the other. Yet, as vast as our galaxy is, it's just a tiny speck in the observable universe, the portion of the universe we can see from Earth. The observable universe is estimated to be about 93 billion light-years in diameter. This means that light from the most distant objects we can see has been traveling towards us for almost the entire history of the universe. Our solar system, a collection of planets, moons, asteroids, and comets orbiting our sun, is our cosmic neighborhood. The inner solar system is dominated by rocky planets, Mercury, Venus, Earth, and Mars. These planets are relatively small and dense, with solid surfaces and thin atmospheres. Beyond Mars lies the asteroid belt, a region populated by millions of rocky bodies, remnants from the early solar system. These asteroids range in size from small pebbles to dwarf planets hundreds of miles across. Jupiter, the largest planet in our solar system, acts as a gravitational shepherd, keeping most of the asteroids confined to the asteroid belt. The outer solar system is home to the gas giants: Jupiter, Saturn, Uranus, and Neptune. These massive planets are composed primarily of hydrogen and helium, with small rocky cores. They are surrounded by rings of ice and dust and have numerous moons, some of which are larger than the planet Mercury. The planets in our solar system are constantly in motion, orbiting the Sun in a delicate gravitational dance. Each planet has its unique orbit, speed, and axial tilt, giving rise to the diverse seasons, days, and years we experience on Earth. The study of our solar system provides insights into the formation and evolution of planetary systems throughout the universe. If stars are the building blocks of galaxies, then galaxies are the cosmic cities that populate the universe. Our galaxy, the Milky Way, is a barred spiral galaxy, a vast collection of stars, gas, and dust arranged in a spiral shape with a bar-shaped structure at its center. The Milky Way is estimated to contain hundreds of billions of stars, along with countless planets, moons, and other celestial objects. Galaxies come in a variety of shapes and sizes. Spiral galaxies, like our own, are characterized by their graceful spiral arms, where new stars are born. Elliptical galaxies are more rounded, with less gas and dust, and contain mostly older stars. Irregular galaxies have no defined shape and often result from collisions or gravitational interactions with other galaxies. Galaxies are not randomly scattered throughout the universe. They are often found in groups or clusters, bound together by gravity. The Milky Way, for example, is part of the Local Group, a collection of about 50 nearby galaxies. These galactic clusters, in turn, are organized into even larger structures like superclusters and filaments, forming a vast cosmic web that stretches across the observable universe. Looking beyond our local group, we encounter a breathtaking tapestry of galaxies, each a vast island universe unto itself. The Andromeda Galaxy, our nearest large galactic neighbor, is a spiral galaxy similar in size to the Milky Way, located about 2.5 million light-years away. On a clear night, away from city lights, the Andromeda Galaxy can be seen with the naked eye as a faint, fuzzy patch of light in the constellation Andromeda. As we peer deeper into space, we encounter a dazzling array of galaxies. There are giant elliptical galaxies, some containing trillions of stars, dwarf galaxies containing only a few billion stars, and everything in between. Some galaxies are actively forming new stars, while others have long since exhausted their supply of star-forming gas and dust. The study of distant galaxies allows astronomers to trace the evolution of galaxies over cosmic time. By observing galaxies at different distances, we are essentially looking back in time, seeing these galaxies as they were billions of years ago. This allows us to piece together a picture of how galaxies formed and evolved over the history of the universe.